Hello and welcome to this Mastering the Machine Automation Academy webinar for the 30th of May 2022. Today's topic was a project that I am working on at American Beverage Depot involving conveyors and inspection. It's titled Spirals and Inspection, and it talks a little bit about CAD and project management and design. Hope you enjoy it. So welcome to this morning's webinar, 30th of May, 2022. This is a Mastering the Machine webinar for the Automation Academy. And I've started including my Automation NTH University logo on here since they kind of helped me sponsor my book. And today's topic is a new ABD project that I'm working on, which involves spirals like this thing here. So what we're doing is we are taking product and sending it up to the ceiling and bringing it across and then sending it down another spiral, and among other things, also inspecting the product. So this will be ABD's first machine vision application. So they're going to have to learn Cognex machine vision systems, and I'll be explaining kind of how that fits in here also. Some of the preliminary stuff here. What is Mastering the Machine? I created a document about 8 years ago called Mastering the Machine and made it available online when you can get it at these points. It really is about machine specification and design and kind of how big companies bid machines and put together quotes and that kind of thing. And I just kind of co-opted the name for this webinar, which also occurs in concert with the Automation Academy, which I started a couple of years ago. Phil's here, and he's kind of toured around the site. He's been a member for a couple of years. And you can find this website at this point. And I'll explain a little bit here of why you might want to check out this website. There are training videos for Allen Bradley, Siemens, and Omron if you like that sort of thing. Training videos where you can take PLC classes. There are lots of PLC classes out there, of course. Mine is just one of many. But there is a library of training and technical documents, and that includes things like my book, which came out March 25th. So I say my new book is out. It's actually not that new. It's now 2 or 3 months old. But I pulled all the book out and separated into 24 separate documents, and I made them all available individually as downloads from the Automation Academy, which is kind of a perk here, considering that the book itself lists for about 75 bucks. And on Amazon, it is anywhere from 56 to 67, and you can get it from Barnes and Noble and different places. But the Automation Academy is $9.99 a month just for the download part, and that book is included in that download. So you can get it much cheaper as PDFs just by downloading it from the Automation Academy. And some people have just joined for a month and downloaded it, and that's fine. They can use the PDFs for whatever they want to use them for. There are things like PLC programming, machine vision, troubleshooting, that sort of thing on there. So pretty good deal. And if you like the training videos, you can also pay a little extra and get the videos. So about ABD, Phil is on here, and Phil has been with me. He took a trip to ABD with me. It's a big beverage, not so big. It's actually small for a beverage manufacturing plant, but they make boxed juices, and they make bottled juices and bottled water and things like that. And one of their problems is they are constrained in space. There is no way for them to expand their plant. They can't build new buildings. They're kind of in the middle of Miami, and they really don't have a lot of space to expand. This is my history with ABD, and the reason I'm kind of posting this here, some people will be interested if they go independent as an integrator. How do you get jobs like this, right? How do you end up doing projects for a company like this, expensive projects, big projects? And the first trip that I ever made out there was back in 2014, and I met the maintenance manager and the plant manager at that time. And they had some device net problems, and they got my name because I taught PLC classes. And I did not teach this particular PLC class. Somebody in Canada taught it. But that person was asked by the owner of the plant, hey, can you come down here and help me with some of the problems that I'm having in the plant? They had, in particular, lots of problems with DeviceNet, and they had a lot of old PLCs that they were trying to control things with. And a lot of those PLCs had proprietary software in them from Seidel and from Tetra Pak. And they didn't have any PLC software of their own. They didn't know anything about really automation. They just did the physical maintenance of the machines, and they would call companies like Seidel and Tetra Pak in to work on their equipment. That's very expensive. A single trip, for instance, from Seidel, they would send somebody out locally from like Atlanta, and I don't know, maybe they'd charge a couple $1,000, but that person did not know how to change anything. That would be just somebody to investigate the system and find out what might be wrong with it. If they had to make software changes, they would send people out all the way from Italy. And the minimum price for that was $20,000. It would be 200 and some odd dollars per hour for a door-to-door trip there and back. So somebody would leave their house in Italy with their laptop or whatever. They would come out, make the change in the United States, and then they would fly back home to Italy. That was pretty expensive. They simply didn't have anybody in the United States that made software changes. So that's kind of how I originally got involved with them. Obviously, DeviceNet, for those of you who don't know, this is an Allen Bradley protocol, and it's an older protocol that was late 90s, early 2000s, and it's pretty hard to configure and pretty hard to troubleshoot. It takes a special set of software, which I do have. It's called RS Networks. And this first trip, I went out there and talked to them a little more about software and where you get the Allen Bradley software. And they ended up buying some of that and learning slowly during this evolution right here, how to change some of their own programs. They had taken classes in it, and then they needed further help. So that first year, I just made a few little programming changes and ran around and tried to figure out what was wrong with their sensors and things like that. And then they asked me, hey, can we upgrade this to a newer system? And I said, sure, it takes a long time and you guys are in production. How are we going to do that? So that's when I began this, right? So we kind of slowly migrated an SLC, which is an old RS Logix 500 platform, into ControlLogix, which is modern. And this took several years. So you can see during this time, I think probably by 2015, 2016, we had most of this, this conversion done. Part of the reason that they had to do the conversion is they wanted to add several tanks to their existing system, and there just wasn't enough room in the existing software and platform to do that. They would have had to add another PLC anyway. So what I did is I actually added a compact Logix, which is a small ControlLogix system, kind of piggybacked it off of the SLIC, slowly replaced it with Ethernet IP, and it kind of evolved into this. So this was all up till about the year 2020. And this is kind of how that worked out. And then February 2020, did some work on their conveyors. We had already added the tank. They had migrated into using ignition, data acquisition. So the basic idea behind this is that as I got to know them better, they started trusting me with bigger and bigger projects rather. So we had added the tanks, we had done a bunch of data acquisition. During this time, the owner of the plant is a fairly young guy. He was at that time in his 20s, he's now in his early 30s, but he learned how to use ignition software and started getting really into upgrading the plant. And you can see some of the different things that happened here. We worked on a shrink wrapper, did a mini CIP system, more data acquisition and ignition. And then Phil is on here, and I made a trip with Phil. I don't remember, Phil, if it was in June or July, but it was one of those two trips that we went out there and we did kind of some data acquisition, and Phil kind of got to tour the plant. And then May 2022 is where this particular project, keep saying product, started. So during that time also, I had to put this note here. In 2020, obviously COVID-19 hit, and at the same time, my facility was destroyed by a tornado. So I worked out of my house for about 4 months, and during that time, went to ABD and did some work. That was almost my only external work when COVID started. So this is a few of the pictures of the history. Some of these tanks, this tank that you see over here was actually added in about 2016, 2017 timeframe. So this was something that I did all the software for and worked with Luis, who's the plant manager. You can see he could have done things in CAD, but he actually did his piping diagrams on a giant piece of kind of glued together paper. So you can see a piece of it here. I thought that was a neat thing. It was just quicker for him to do that. These little diagrams here are all these little pipes for connections, and we kind of annotated things. And then I later ended up documenting it in the HMI software. So here's another one of his drawings. Here's some of the pipes that were part of that system. So this is very piping intensive. And my only experience with pipes and things like that at that time was from teaching oil and gas people and learning P&ID diagrams, things like that. So I ended up kind of recreating this in HMI software and using that to create kind of formal documentation for where all the connections were. And I have another picture of that, but not going to put it here. So here are some more pictures. This is part of the Tetra Pak line, which I think Phil got to see some of this. They process all these bottles through here and have spirals and things like that in that. But these are kind of smaller processing lines. The one that I'm going to be working on here is a little bigger. This was a data acquisition drawing we did on Juan Pablo's whiteboard. It just shows some of the design steps in initiation of a project, right? You have to discuss a lot of the stuff, and I'll be talking a little bit more about that here in a few minutes. So where do leads and projects come from? You know, a long time ago, I tried to send out flyers back before the internet was out, and I tried to get new customers that way, and it just never worked. Advertisement, things like that, maybe it works for larger companies. You get to build a name, but for me, it's always been, and I've owned a small company of about 15 people. It always came from networking and relationship building. You would get to know somebody at a plant, and they would try you on something small and then something a little bigger. And over time, you would they'd ask you, hey, can you automate this press system for me? Can you build a material handling system? Something like that. And so you would move up to bigger and bigger projects. But that's kind of why I put this here. It doesn't really come from advertising so much, although of course the internet's pretty awesome now, and you can put ads out on LinkedIn or wherever, and you may get somebody's attention, but it never really worked for me. So that's where all this comes from. I kind of wanted to talk about that, about where my connection with ABD came from. About this particular project, first off, why are they doing this? They have an existing material handling system, but they need more space, and they're going to put a fourth Tetra line, and there's simply not room for that line right now. There's room in the Tetra room for another filler, right? So they can run pipes into there and they can fill packages. But if you tried to run the conveyors out of the Tetra line, there isn't room. This is the Tetra line, and you can see it's pretty crowded. There are a lot of mezzanines and things jumping over, and there's just not any more space in this room. So that's the justification for this project. This is the PET line. The PET line fills bottles, right? Blown bottles. So there's a blower here, and it takes the empty bottles through here, sends it into this filler. This is zone 1 of the PET line. And there's a picture of it, right? So there's some of the swirly things going on, empty bottles. At this point, they go into the filler, and then they come out filled, and they move through this area, and they get labeled, and they get inspected, and then the Bad bottles get sent off here into a bin. A little more on that later because we're going to have to do that again, reject some of the bottles and things. So that's zone 1. Here is zone 2. Zone 2 is coming out of the filler and going through that area right here, and then going into a great big kind of a swirly table where all the bottles are just collected up, and then they move down this conveyor into a shrink wrapper. The shrink wrapper is another project that I've worked on for them. It's very old, and at that point, bottles come out as packages. So they typical like bottled water that you would see in the store or bottled soda. They anywhere from 6 1.5-liter bottles up to I think 24, either 16 or 24 smaller bottles, like 20-ounce bottles. And then they come out of this. So then it goes on to zone 3. By the way, these pictures, again, I kind of use them for documentation, but these are WineView HMIs. So WineView makes very inexpensive HMIs in China. They're a kind of a takeoff of WineTech, which is a European HMI, but I actually take their screens and just print the screens for documentation. This is kind of shows where all the photo eyes are on the line. They light up light green when there's a part in front of the photo eye. This is just a screenshot, so you can't see it actually operating here, but that's how I documented this. So this is a little bit of zone 2. This is in the back room. This is the filler, and these are some of the bottles coming out one by one, right? And so that's a little bit of zone 2, and then we get into zone 3. So zone 3 is going to be removed. And the reason is it kind of blocks access to this big empty space. So a lot of this empty space here, they actually stack pallets here. And it really is not very well used space. There's some racks back here and things like that, but they want to be able to use this space, which is where those spirals come in. So this is a picture of one of the spirals. Spiral is here already in place. You can see another spiral in the back. This is the shrink wrapper. So this is going into the shrink wrapper here, heat tunnel. And I kind of put a picture also of this is a case turner. And this is a used case turner that they bought from somewhere. And we're going to use it to turn the cases and then send them up the spiral. And you can see here, the spiral is not very wide, which is where kind of the inspection comes in. You're going to send the bottles up the spiral, send them across, and there's the other spiral in the background. So that's going to leave all this space open, right? So you can see stacked things here. So that's going to leave room to put the Tetra line underneath those conveyors, and it's going to give access so they can pull a lot of this stuff out here. They're constantly moving things around and trying to figure out how to use their space more efficiently. So zone 3 will be removed. Zone 3 again looked like this. It had 6 or 7 conveyors, and they fit into a palletizer. You can see they're Spanish speakers, so we call it the Palletizadora. There are 4 palletizers there, but this is the only one with a Spanish name. The other ones are all top tier palletizers, and we just call them top tiers. But this one, the Palletizadora, is an old palletizer, and you can kind of see a piece of it back here. But this is what we're replacing it with. So where we had 6 or 7 conveyors, we're pulling them all out. And some of my command decisions here, those conveyors all had odd numbers on them. So 401, 403, things like that. So what I decided to do, rather than reusing those numbers, because these do completely different things, is I replaced them with even numbers in the 400 range still. So all this new zone 3 stuff is going to be 402, 406. That 412A and B is the case turner, which already exists. So I don't need to put a VFD in there or any of that kind of stuff. Then the spiral, right? So this is the spiral, goes up. And then this stuff, this is abbreviated. These are real short looking, but it actually extends a lot farther. And then the spiral goes down, and the parts, the bottles come out, in packages on these two conveyors and then feed into the palletizer. So this last one, 442, is the palletizer in feed. So there are a few changes here. I had to make some decisions when I went down and talked to them. We originally started out by saying, well, why don't we just piggyback off of the existing Siemens 300 system? But a Siemens 300 is a pretty old PLC, and they really don't like Siemens that much there. They've kind of migrated, since we built all those tanks, into ControlLogix, which is much more modern. And then the clincher here was when we decided to add these cameras. So there's an inspection here before the oven and an inspection after the oven to make sure that the packages are in the proper form to go up these spirals. We don't want stuff to get stuck. These cameras integrate very easily with Allen Bradley. So they communicate directly. They have EDS files, and so you get all kinds of data about what failed about the package. So we'll be setting these cameras up, and they will count the number of caps and things like that, and whether the package is too wide. If it's too wide, we're going to push it off into a bin here. And we had to kind of design all this on the fly. How are we going to move these, right? How are we going to inspect them? How are we going to reject this into this bin? And all this happened over the last, I probably talked with them for a week before I went down to Miami this last time. And then, of course, on site, I spent 2 weeks working on all this design, including a lot of CAD drawings, and I'll kind of show you some of those. But all this stuff kind of came up over the last couple of weeks. They were things that I think we discussed maybe over a period of months before that, on and off, but never really got serious about the design, never talked about exactly how many conveyors we're going to use or anything like that. But it's kind of evolved into this. So this, believe it or not, I drew in PowerPoint. It was the quickest way that I could do a layout without, CAD is great. And I did a lot of CAD work during this trip, but it's harder to print out and it's harder to make little boxes and things. So I just did this as a tentative layout to show where everything was at. This is what we have to work with. This is all used equipment. And you can see here, there is a pallet full of old conveyors. And they gave me a long list of conveyors. There are probably 30 conveyors that they've bought in auction with different curves and straight pieces and everything. And you can see kind of what their conveyors look like here. These are all belt conveyors, and there's other stuff in here too. You can see there's a little wheeled gravity conveyor. This is all out in a big shed outside, but they buy things at auction, and so they're able to do things a little less expensively rather than buying a full new system. So they bought these spirals at an auction. Juan Pablo, the owner of the plant, is very good at finding things like that in auctions and bidding on them. And so that's where all this came up. And they've probably been collecting this stuff over the past year. And all this stuff's just sitting here, and it's hot and humid out there, and it's probably deteriorating a little bit. So we'll have to clean all this up and fix it up before we actually build it. All of this is 480 volt stuff. Again, 12 new drives are going to be used to run these conveyors. And then, of course, this device here already has, where is it? This device here, the case turner, yeah, there we go, already has drives on the side of it. So there's one on one side and there's one on the other. So all told, there are 14 power feeds. So how did I start out designing this? So I arrived there May 16th, and we sat down and we talked about it a little bit. And I literally started my drawings and my spreadsheets that day. So preliminary design, kind of hand sketches and drawings. And then I'm going to show you the spreadsheet that I created. I'm a big proponent of using spreadsheets. Even if you don't know what's going to go on them, go ahead and start the spreadsheet in the beginning. So here is a picture of the first page that I made on this spreadsheet. And I just put here motor number, right? Motor number 1, 2, 3, I really didn't have numbers yet, but then I said station designation, and this is where I came up with those, even numbered stations, and they're just arbitrary. There's nothing magic about this. 402, 406. They already had 401, 403, 405. So I just kind of filled in the spaces around that and listed out everything that we would probably need. After doing that, a hand sketch that looked very much like this thing here. I kind of did a hand sketch with the case turner and just little boxes and with all these numbers, and then turned it into this little spreadsheet. Then I copied this and moved it over here into the motors spreadsheet. So it looks pretty much the same. And I had to figure out, okay, what kind of power is going to be required for this system? And I didn't really know, but I put the horsepower of all the motors that we had, the offset conveyor and things. These were all, we went out and looked at those pictures that you saw before and looked at the nameplates on the motors, and most of them ended up being 2 horsepower motors. Some of them we didn't really know. Actually, I can probably change this here. Copy this, and they're 2 horsepower, add a gas and paste it there. So that's literally how I do this. And I put the full load amps for 2 horsepower motors. Interesting point here. So I showed you my book before, and that book in the back of it has a couple things that came in useful for me that of course I don't have memorized, like full load amps for motors. How much current does a 480 volt 2 horsepower motor pull, and what size wire should you use for it, right? Well, that's in that troubleshooting and maintenance book. So I pulled that thing out and I used it for both CAD examples and for sizing of things, right? For ampacities of motors and things like that. So then I added everything up, all the full load amps, and came up with, I think, 58.1 full load amps. 6 gauge wire turned out to be the right size wire. So all this is very kind of informal stuff, right? Starting a spreadsheet like this. And you have to do all that before you start your drawings. I also started collecting tentative part numbers. A lot of this stuff was already in the plant. We knew we were going to use control logic, so I put all the items that would typically be in a rack here. You can see this is an L63, which is an older processor, but they have one, right? It's in the plant, and they have a lot of other L63s, so we decided to use that. I'll show you a little bit about how the panel was sized here in a minute using CAD. And then all these things are kind of collected, right? As I went through the CAD drawings, I came up with a lot of these parts. So now a little bit of a look at, let's see, the CAD drawings. So begin, right, examination of the existing line and the plant components. Of course, I'd worked on this existing line a lot already, so I was able to pretty much dive right into the CAD drawings. So now, an interesting note here also, it has been, I would say, 16 years since I did a full CAD drawing. And the reason for this is at that time in 2006, when I closed my old company, I still had to fill in spots. If my CAD guy was busy doing something else, I would draw the CAD. If my mechanical guy was busy doing something else, I would have to fill in on mechanical design, whatever. But it's been a long time, and I'm not really, super experienced in AutoCAD, but I just wrote a book on it. So it was very handy, and I was able to use a lot of the examples from Automation NTH. So this was the first page that I drew in the CAD drawings. And a lot of this, right, it kind of evolves as you go on. You can see here, there's all of the feeds, right, 5.1 full load amps. For those who don't know, this thing is called a single line diagram. And what a single line diagram does, it represents 3-phase power as a single line, right? So it shows things like disconnects and circuit breakers. And this is how you can kind of do a tentative layout and figure out sizing for everything. And a lot of this is for safety. You want to make sure that you have short circuit interrupting ratings high enough, right? 50,000 amps, this thing can interrupt this particular circuit breaker. So you want to pick things for these components that can handle all this current. This is 6-gauge wire. It's 50, 60 amps, and it goes into a power distribution block, which I'll show you kind of the panel layout and show you where that thing is. And this is all the 480 stuff. And then you get down to this transformer, and it transitions into 120 volt stuff. And there's the PLC. There's a big power supply, big 24 volt power supply, and a big utility outlet, which I didn't even know what all is going to be attached to this, but probably things like, of course, you can plug your laptop into it, and the lighting for the vision systems will probably be on this outlet also. Everything else is pretty much 24 volts. So you have a lot of 480 volt motors and drives, right? And then you have safety stuff down here in the 24 volt area. This is the safe torque off for the VFDs. I'll explain a little bit of that when I get into the drawings here. You've got an HMI, you've got DC for the output. So all this, again, the book's very handy in showing how these CAD drawings are laid out. And this is like a preliminary drawing. These actually don't get given to customers most of the time. This is a design document, usually in a machine building company, that you would use just for sizing components and showing the overall distribution. The customer doesn't usually need this because, hey, everything's actually 3-phase. So that, as I get to the next drawings, you can see the actual, right, electrical drawings. So this is page 4, which is why it has the numbering system 400 here. So all of the components are numbered based on these line numbers. Another thing I did, I kind of made a command decision. I did not do this in 11 by 17 because I don't know down there what kind of printers they have, but the guys building the panels have to deal with whatever they have in the plant. I see a chat here. Let me see what happened. Can we see the IO list? Yes, I will do that. Let me show you the IO list here. Can we be back? Yeah. So the IO list is a really good point. So what I usually do whenever I make an IO list is I start out with safety stuff, right? In general, you're going to have a master control relay and some e-stops, things like that. And you're going to have a power on reset button, usually the green button that's on the front of the panel. So that is these things right here. And these numbers actually come from the drawings, but that's kind of where I usually start on my IO list. And this is slot 1. It's the first IO card. And you can see there's some spares in here. We can always add more cards. This is photo eyes and proximity switches. And there is room for only one spare here. However, one of the things you can do with Allen Bradley is you can take an Ethernet connection, and I can put remote like Flex IO or Point IO up on the top of the conveyors or at the far end, and I don't have to use all this as spares, right? So these, you'll see when I get to the drawings again, I actually made these sensor terminal blocks. So there's 10 of these in here, and you can plug the sensors directly in there. This had to do with the panel layout. As the project evolves, you'll kind of figure out what size terminal blocks and things you need. A lot of the IO here has to do with simply monitoring the drives. Is the drive running? So I've got a running input for every single drive. Now you might ask, why didn't I use Ethernet IP to connect to the drive like I'm going to do with the cameras? And the answer is we are having a global supply chain shortage. And right now, anybody is having a hard time getting drives. And from Automation Direct, which is where I often get some of my drives if I'm not using Allen Bradley drives, they had plenty of drives. They did not have the Ethernet IP cards that go in there. They were not going to be there until probably the end of July or beginning of August. So what's going to end up happening is we're going to wire all this in there hardwired. We're going to give speed references. You'll see here, right? There's all my speed references, analog outputs. This is the old school way to do this. but we have no alternative. We can't get parts. So I've got running an alarm, right, for every drive. Is the drive running? Is the drive in alarm? A few spares there. And then I've got outputs starting right here. I've got a run control relay back to zone 2. This is the thing that tells zone 2 to stop. So if it doesn't have this input, that means that the zone 3 is not on. So you notice I didn't put this zone 2 stop. I made it run, right? So if that disappears, somebody cuts the line, that stops zone 2. That's the way we want to do it. Little story here about the stack lights. I had this IO list, green, yellow, red, right here in a row. But when I got to my drawings, it became very difficult to represent this by putting it all on the same side of the card. So I spread them out. I changed my IO list as I went along. Reject pusher, this is the thing that pushes the bottles off of the line if they fail the inspection. These are the outputs that tell the drives to run. These are the speed references. So these are 0 to 10 volt references. And then safe torque off. This list here is basically all this is safety wiring. And I did this for my own references as I was doing the drawings. So hopefully that answers your question, Abu Liban. So he's on this call also. So this is where I actually started the drawings. Here is the 480 volt feeds. And I put a lot of notes in here, all wires from the power distribution block, which is this big old thing, to the motor circuit protectors, right? R14 gauge black. They can ask me questions as they build this panel. I've got a panel layout, lots of drawings in here as part of that. So like I said, I started this drawing on May 16th. I think this particular drawing probably says, let's see, 18 May. So I completed it and dated it as of that date. There's a continuation, power distribution block 1, power distribution block 2, and a lot of this had to be sized, right? So all these motor circuit protectors, these are manual. They have overloads built into them, and you can turn them off. So this removes power from the drives, and it disconnects itself if there's an overload of some kind. So that's a little of the 480. And then here you can see power going out to the 120 volt transformer. And then you get into the 120 drawings. And I always refer back, comes from sheet 6. And there's our big power supply. It's 20 amp, it's not huge. He actually had a 40 amp on site, but I didn't want to overload the transformer. But if they want to change that on the fly, they easily can, but they would have to increase, right, this circuit breaker. They would have to increase the size of the wiring, right, for all this. So if they make that change, then I'll go modify the drawings at that point. Here is the 24 volt stuff. And again, I took this directly off of the single lines. So that's how that design part works. This is pretty complicated, and I had to use my own book again for this, right? This is a safety relay, and I had pretty good drawings in my own book of this from Automation NTH. So I use their drawings as references. Little story I wanted to share. Like I said, it's been 16 years since I did this, since I've done a full set of drawings. And I didn't have a library, right, for any of these parts. So a lot of people use AutoCAD electrical, and they already have things like fuses and transformers and receptacles. I didn't have any of this because I don't have other people's AutoCAD drawings. I don't even have my old company's AutoCAD drawings. I think we were on AutoCAD 12 back then, and now we're on like 2020 or 2023 version even of AutoCAD for a lot of this stuff. So I didn't have libraries, and I had to create these on the fly. So that's part of what I did over the last 2 weeks, is I had to create these objects. But the nice thing is, once you draw one, you simply copy it, right? You keep it on Snap and you copy it down however many times you need it. And all this numbering, right, all these fuse numbers and things like that just come from whatever line they appear on. And this is a pretty standard way of doing drawings in automation. So back to the safety, you can see there's a lot of safety stuff here, e-stop 1 through 4, and there probably will be a light curtain in here too that I'll have to add later. And then what these do is these remove basically power from the drive. So if you hit the e-stop, these safety relays will remove power from the drives or the pushers and things like that, right? So this is all a safety thing. And then these drawings, you can see here, go out to all the safe torque off of the drives. And then in this case, this is the case turner. Now, none of this stuff's particularly dangerous, right? It's all just conveyors. So it's not really a super hazardous thing, but I kind of told Juan Pablo, this is a good opportunity to go ahead and wire things up the way you would do other things that could be hazardous later. Like if you ever get into robots, you'll have to do this. You'll have to remove power on 2 channels from the robot. You want to do things the right way and use a safety relay like this. All of these items, I found Automation Direct very convenient because Automation Direct has all the cut sheets. I was able to download files for a lot of the devices and the drives and things like that. Pictures of the drives, got pricing for everything. Some of this stuff I got from Alan Bradley's website and modified it for my own use. There's the PLC showing what's in each slot. So a lot of this is for the people building the panel. And then a lot of this is subject to change. This is the Ethernet addresses that will be used for all the devices later, right? The VFDs later will be on Ethernet IP. There's my first drive. Once you do the first drive, it's really easy to copy it multiple times and change the numbers as you go along. So you spend a lot of time on the first one and then you copy it to the second one. Now, when I got to the third one, this was the case turner, and it's a different layout than these drives, right? It's a completely different drive. So I had to look that up online and find out what is the pin out for this particular drive. It's a Lenza 1.5 horsepower, and that's even a guess, BFD. I couldn't find the horsepower on the drive itself, but somebody said it was 1.25, and there was no 1.25 in the list that I found online. So these, of course, are 2 horsepower, brand new Durapulse drives from Automation Direct. So Automation Direct's really good at keeping all your documentation there on their website. So you can see lots and lots of drawings here. All the numbers are different, right? And these refer back to, so this 00742 is from page 7. That's how these numbers work. This is page 30. So I can refer back to where these connections are. And sometimes I'll even put a note here like these are 480, 482, 484, and it goes to sheet 4, right? And so that's what these references are all about. So these lots of drive drawings here. And then let's see, we got into back to the IO list, right? I had to hand draw this myself from Alan Bradley's pinout of their cards, right? I just took this and I made these little symbols here. So these are a part of my library now, right? Photo eyes and proximity switches and things like that. I had to stagger them a little bit just to make them fit. If you lined them up, then of course this little line would hit this. I had to spread things out. It took a lot of extra time. And I kind of made up my own drawing style as I went along here. I put things that I would like to have as a programmer, like the actual address in the software for the inputs and outputs, right? A lot of people don't put those on there, but I found it useful. These are wire numbers, right? Another thing I want to mention here, normally, right, I drew this. Normally somebody checks it and somebody approves it. And I didn't have anybody there to do that. I would be checking my own work and approving my own work. So I went over and over it. There's nobody else there that can really do that. So I'm kind of on my own. There's another card, right? Here's all the drives, what page they're on, that sort of thing. So this is all PDFs of the drawing set. There's a kind of a funny control relay showing the pinouts of the relay itself. There's a solenoid valve. That doesn't have a label on it. That's going to need to be put on there. 2908, this will be solenoid valve 2909, right? This is easy to correct later. More drawings here, more pinouts. This is all analog. So that's kind of what I spent my time doing. This, originally, I had this drawn in a single door cabinet, and I don't have the actual cabinet outside here. They bought a used cabinet. And originally we said, what cabinets, what enclosures do you already have? And we had I think a 5 foot tall by 2 or 2.5 feet wide. So 60 inches by 36 inches. It wasn't big enough. So Juan Pablo went online and found a 60 by 60 inch cabinet. Now, for those of you who are into millimeters, right, I don't have the conversions for that. In the US, we use a lot of inches. I could convert that. If we would have used a Rittal cabinet, this would have been in millimeters, right, or meters or whatever for the sizing. But I drew all this in standard layout. And so this was the overall layout. And you can see here, this is on an 8.5, 11 sheet of paper. So it's hard to read anything, but then I broke it out into more readable format. So here's the PLC. There is the layout of the first set of terminal blocks, which are up here, right? This is the labels that'll be on the terminal blocks themselves. You can see here, I've got kind of 10 sensor terminal blocks, and then I've got a lot of individual terminal blocks. And as I put these on here, I also counted them up in the parts list, right? That was here. So all this works hand in hand as you're doing this design, right? You're collecting the parts, you're doing things like counting terminal blocks. How many terminal blocks are there actually in this drawing set? And I said 138. By the way, they come 100 per box, so they'll order 2 boxes or 3 boxes or whatever. Lots and lots of different things. And if they have questions, of course, they can ask me via WhatsApp or email or whatever. So there's some more terminal layouts, more fuses, safety control relays, right? This is the wiring for that. Did I do a good drawing of those? That's in the IO drawings, I hope. Let me see. There's power distribution. Actually, they're probably going to need more information here because the safety relays, the pinouts are way up here on another page. So it's not real obvious. Actually, it says 931, 932. So if you go to page 9, then that hopefully would have all the drawings. So this is what I spent those 2 weeks mostly doing right there in Juan Pablo's office. So this actually shows the pins, right? 41 and 42, 41 and 42. So they'll wire these however they can. We spent a lot of time also, who is going to wire these panels, right? I tried to find somebody down in that area, and we really couldn't find panel builders that had capacity to build this panel in June. That was already in Florida, right? I possibly could have gone up to Indiana and had somebody build it, but that would have been really hard interfacing back and forth between the plant or myself, because as some people know, I spend a lot of time working with other people also. I don't have full time that I can devote to this. So a little bit back to this, right? Began the CAD and the single lines, more discussions. Completed the electrical CAD. I spent 75 hours on my total stay down there from May 16th, including taking a short vacation to the beach with my wife for 2 days and then coming back to the plant. So I did 2 4-day weeks and then came back here. So 75 hours in 8 days. So I was able to time myself. How long does it take to do those drawings, right? So what's next? This is the next project steps, right? Panel fabrication. So how are we building the panel? We're collecting all the parts. The maintenance manager, Guillermo, is making sure that all the parts exist. And there is a guy in the plant who could build the panel, but he's very, very busy. So they actually brought the brother of one of the workers in the plant from Argentina who has built panels there before. He's coming up here for a couple months, and he's going to build the control panel right there on site via these drawings. So if he has questions, he'll get with Guillermo. Guillermo will get with me, and I'll be working back and forth with them. They are also going to be installing the conveyors around the existing line. All the overhead stuff they can hang, right? Build some structural stuff and put the conveyors way up at the top. And another thing that's going to happen is very interesting. I ordered a small belt conveyor today, and I have several cameras for machine vision here at my facility in Nashville. I'm 1,000 miles away from their location, right? I actually drove down there. Sorry, I keep flipping from screen to screen here. If you click, it goes to the next screen. But we're going to be doing a bunch of machine vision testing on bottles of water. So I brought back 3 representative cases of the water in the sizes that we need, and we're going to be putting cameras on them and seeing what they look like and testing them out, and at least determining which cameras they need to get for the machine vision. This will all be Cognex, probably a 2000 and a 7000. And after I kind of shut down this screen share here, I'll show, I've got a camera behind me and show you a little bit of what that looks like. So we're going to be testing that. Juan Pablo's actually coming here. He's the owner of the plant. He's coming up here to Nashville for, I think, 2 or 3 days, twice, right, in June, to mess around with machine vision. I have to write the PLC and HMI programs before August, and then integration will be, okay, they're going to have to shut down the lines, and they'll run it until the last minute on the floor, and then they'll have to start, okay, we can shut down the PET line for, say, a month, something like that. We'll do a startup after they get installed for about 2 weeks. I'm sure I'll have to be there, and then we'll do some training. So that's a little bit of a look at what this project is. I'm going to stop my share. Looks like we got a couple people online. How you doing, Phil?
So far, so good. I really appreciate going through all the electrical CAD drawings. I don't have as much experience with the electrical CAD, so that's interesting to see and learn about.
What's interesting is I did CAD drawing when I had my own company. I had to. I was the only person when I started to do it. And I taught some of my employees how to do it, but I don't know that we did things the best way, the correct way. But one of the good things about, give you a plug on my book here. Let's see. One of the good things about writing this book is the last part of the book was CAD drawings from Automation NTH. So what I did is I took one of their machines and I broke it apart and explained what everything did. And I took pictures of all the terminal blocks and the components, the robots, things like that, and then explained the CAD and the numbering systems according to the components. So it's interesting that timing wise, I wrote this book up till about March, and then ended up using it for my own project, right? I don't have all that stuff memorized, so I was able to use the resources out of that. But yeah, so you've been to the plant, you kind of recognize some of those areas in the plant, and what they're doing, I wasn't able to kind of show it there, but their next step is they're going to take and add a Tetra line. And since they don't have enough room in that room, they're bringing the conveyors out and underneath those spirals. So it's going to extend into the PET area. And they're talking, while I was there, they said, you know, we may just sell that PET line, but I think I explained to you last time, they have to provide water. When they sell box juice, most of the people say, well, we need to fill the rest of the truck with water. Otherwise it's a waste for transportation. Send us a bunch of water too. So they're either going to maybe build another plant and somewhere, maybe North Florida or something, and put the PET line in it, or get rid of it completely. And I kind of asked them, well, don't you have to sell water? Maybe they'll buy water from somebody else to fill the trucks. I don't know how that works.
Interesting.
Yeah. So any questions? Oshojeme Olugun, I recognize your name. I forget where you're from. Are you from Nigeria? I think he's muted. And Liban is a new attendee for this. I haven't seen his name here either. But anyway, we've got a couple other attendees on here. So that was kind of what I wanted to show you. Let me see. Do I have another? I do have another full set of the documentation. Here we go. So during this trip, I think I showed you, Phil, one of the things that I do when I do design like this is I will handwrite notes. And so a lot of the hand stuff that I did was here. I think it was maybe only 7 pages, but you can see a lot of the lists and the safety stuff that I hand wrote. And then some documentation is given to me by ABD. So this is a list of all the conveyors they had on those pallets. And I am going to, at some point, take this and put it in another spreadsheet. Here's the existing conveyors with the horsepowers, and here's the turns. And so by August, they're going to have to choose which conveyors they're going to put in which locations and make them fit, right? So the mechanical aspect of this is sort of we have, let's see, it says here 27 conveyors in stock of various lengths. Now, how are we going to make those fit in the lower sections or the upper sections? And if they don't fit, they'll have to cut them, they'll have to make them fit, or they'll have to buy other conveyors, right? They tend to use a lot of the stuff that they have around the plant and just, repurpose things or buy things in auction, and they save a lot of money that way. It's kind of a good system, an inexpensive way to do things. I'm going to guess if they were to have somebody else do this and try to have somebody do a turnkey project, it would easily be $500,000, easily. And there would be a lot more than just me designing it, right? But the plant manager is pretty good mechanically. They know definitely how to shorten conveyors and change things. What I kind of provide for them is things like, I have a lot of experience in machine vision. It's been a while since I've done a lot of it, but when it came time to say, how are we going to inspect these packages, make sure they're all there and that nothing gets up into the spirals that's going to get stuck. One of their big worries is if you have parts backing up on the upper conveyor, eventually they're going to fall off, and they would fall from about a foot height and hit the ground and probably hurt somebody really badly. So that's why we're inspecting everything and making sure that, and we're putting cameras up there too, but they're not inspection cameras. They're going to be just viewing cameras, right? You can just look like the Lorex, Ethernet type. Yeah. So, but we're inspecting them all. And so some of the things that have come up in discussion is, could we use a line scan camera to shoot up in between conveyors and look at the bottoms of the packages and make sure that they are sealed correctly? And so that's something that may be added. And so whenever I do these designs, I say, well, do we have enough extra power? Do we have a big enough cabinet to add more space, more drives, right? And so I'm going to go ahead and go back to share here in things like those panel layouts. There we go. So let's see. CAD PDFs. Nope, that's not it. So hard to find things managing all this. There we go. So the panel layout, when you do things like this and you make sure everything fits, I'll show you there's quite a bit of extra space. Right, so we have all this space up here. This would basically be for more 24-volt stuff, little more if we had to add another power distribution block. So when you lay things out, you leave extra space like this. Like there's even some space here for something. I don't know what this would be, but if we had to expand the drives, we could add a couple drives down here. If we have to add more 24-volt stuff, we can add it down here. And as I said, the rack's full, but we could put a bigger rack in here, and we could also use remote IO of some sort, right? Ethernet IP type IO. So there's a lot of flexibility when you design systems like this. You want to make sure that everything fits or has the ability to be expanded. So that's the general idea. I'm going to go ahead and just kind of announce the next webinar here, and then we can talk a little more. The next webinar, as far as I know, is going to be June 18th, which is a Saturday again, because I have to spend a lot of time at Automation NTH. We'll probably do more maintenance and troubleshooting in industrial automation from my book. But I may have a guest on. Phil, if you want to be a guest, if you have something specific you want to present or anything, that would be awesome. Or somebody else, you know, I haven't had a guest for a long time, but so that is pretty much all I mostly had to say here. Let's see, can you send out invites earlier to Gmail accounts? That is difficult, and I'll explain why here in a second. We'll go ahead and have an offline discussion here, so I'm going to stop share. So the thing about announcing these things, right? I usually know within a couple days that I'm going to be having a webinar, but it might be coming up on a Saturday, and I don't have a way to broadcast emails other than the people who have subscribed to my blog, right? That list, I do have a, you know, as people like download these documents and things, then I do get their names, but I honestly haven't checked that list for probably a year because I don't send out emails regularly. I am a one-person company. So, and I spend a lot of my time, 2 weeks every month I spend at Automation NTH, which is an engineering firm here. You can see here this summer, I'm spending a lot of time down at ABD and working on their projects. In addition, I have automation training, which I teach remotely for them, and I'm doing 1 week every month for them. So there's 3 weeks right there. And then the rest of the time, I'm even teaching a class for Nissan coming up in September, and I've been paid for 2 weeks of development there. So I just don't have a lot of extra time, and I don't have a way to manage all those email addresses, but I do put things on LinkedIn regularly. I announce them ahead of time. I have these every 2 weeks roughly. And if somebody contacts me on LinkedIn, I know Liban or Abu, you are on LinkedIn. So you will see my announcements, and feel free to, if we're not connected, go ahead and, you know, contact me, and I'll let you know when the next webinar is. But I don't really have an easy way to email everybody. There is an email list that's basically generated from people who subscribe to your blog and things like that. But I just don't have a lot other than advertising the Automation Academy. I don't have a lot to say. And I don't have a lot of time to say it in. So that's one of my problems. But on LinkedIn, I'm super active. I'm there every day. I at least check my LinkedIn, see if I have messages, correspond with people, send messages back and forth. That's probably the easiest way to contact me. So not really sure where to go from there. But yes, that's going to be the best bet. I'm actually thinking of hiring somebody to manage some of this. I'm kind of convinced that the Automation Academy, with proper advertisement and regular engagement, I could probably support somebody doing regular engagement, right? Sending out invitations and managing the email list and advertising my books and things like that. Because honestly, several people have joined and they don't even log into the Automation Academy, but they're still members after like 2 years. And so it more than pays for itself. And if somebody were to constantly be on there kind of telling people, hey, here's a $75 book that you can get for $9.99, you know, by joining the Automation Academy. If somebody would do that regularly, I don't have time to do it, but if somebody else were to do it regularly, I think it would become a pretty good self-supporting thing. And I could honestly use the help. So I'm thinking of doing that, thinking of advertising for I don't know what you'd call it, personal assistant, LinkedIn aid, advertise, marketing person, whatever. I don't want to just pay a company to do it. I tried that and it didn't lead anywhere. They don't know anything about what I do, and I'd have to educate them, and then I'd have to pay them a lot to educate them. I'd rather pay somebody that's like a contractor or something, rather than going to a big marketing company and just relying on marketing. But anyway, that's why I kind of, don't advertise and things like that. Just not enough time. Phil and I have talked about that in the past. I'm a little scattershot as far as how I, operate. I'm mostly into the design stuff, not as much into the marketing and advertising. So what else is up, Phil?
Oh, just in regards to that, I have a lot of success just kind of finding your webinars through LinkedIn. That's primarily the easiest way that I located is about a day before you'll send out an update, and then I'll have time to set the calendar then. And if it doesn't work out, well, it doesn't work out. So
Exactly.
So that's fine too.
So, and I got a message from Abu about applying, for a position doing the advertising and stuff. One of the keys for me is that it is somebody local, somebody that I can meet with. I need to meet face to face so that I can hand people pieces of paper and show people stuff. The other thing is it's going to be somebody who knows both automation and knows marketing. Marketing is a critical part of this, and I don't know enough about it. I've learned a lot by attending the membership academy and things like that, but it's going to be somebody, it has to be somebody that knows a lot more than I do about the marketing aspects of this and can consistently engage with people. But I think it's important to find somebody, I mentioned before, my daughter owns a branding company. She does marketing. She owns a company called Huckleberry Branding, and they built part of my website and everything. And even her, she doesn't have expertise specifically in that area. And she doesn't have the day-to-day bandwidth that I would need. It's probably going to be somebody that's, 30 to 40 hours a week and consistently keeping up with, people who log into the site and putting my ads out for books and things like that. Somebody that really knows what they're doing more than I do. That's the issue. But Prashant, I noticed that you're here. How you doing? Oh, he just disappeared. So yeah, Phil, any suggestions on the next topics also? I thought this one was a good one. And of course, I'll keep up with this project. At some point, I'll probably go into showing some of my HMI screens and PLC programming for this project. I'm going to probably start writing the program for this in July. That's my guess. Probably take me another 2 weeks to write the program and the HMI program to some degree. I'm pretty fast at programming. That's really more of my forte than drawing. But I did manage to put together a full CAD package in 2 weeks. It's about 42 pages or something like that, and worked out pretty well. Yeah.
I could see there being some need or desire for how you're connecting the Cognex machine vision back to the PLC.
Yep.
Just kind of emphasizing what the Cognex system is doing, how it connects to the PLC, and some of the capability, just specifically with that connection.
Yep. For those who don't know, I'm going to pull this off here because it's actually going in the other room. This is a Cognex 7000 machine vision system on a little arm here. And I have another one over here to the right. I have a 2000 and I have a 7000. I have an old 5000 also, but this is pretty much the camera that's going to be on there. This is pretty elaborate, and I will do that. I will definitely talk about the Ethernet IP, the EDS file, and how this integrates. I'll probably at some point after I set this thing up also do a webinar on machine vision specifically. How Cognex works, the spreadsheet system, the easy builder, and all that. And I'll at least mention in passing how it interfaces with ControlLogix. One thing about Cognex is they are really kind of in bed with Allen Bradley. So their integration is just very tight. All you have to do is drag the camera over and stick it on there, and it builds the data structure and everything for you. And you can get all kinds of information in there. But the good thing is also at Automation NTH, they have a whole vision lab, and they have an expert at Vision Systems there that I can kind of deal with and talk to and maybe bring onto the webinar. We'll have to see. But that's a little bit of a look at the camera that's going to be on one end of it. And then the cheap camera is cheap is relative. It's still, I'm sure, a $3,000 camera. This is the little guy. And they call this a smart sensor more than they do a camera, right? And what it's going to do is simply look at and see whether there's film on the packages before it goes into the shrink oven. If there's not film on it, we don't want to try to reject it because loose bottles would be kind of a disaster. So we stop the line immediately with this. This will be before the shrink oven, and then the more elaborate vision system will be on the line, making sure that all the bottles are there and that the package isn't too wide and things like that. So I'll definitely be doing that. I bought a conveyor today. I bought a belt conveyor. I hope it works well. It's a Chinese thing, and it's definitely cheap. Cheap is relative also. It was $700 and some, but it's like 23 inches wide and 50 some inches long. And I don't think it's real heavy duty. I hope I can easily change its speed and things like that remotely. But the main purpose there is just to set the bottles on them and trigger the camera and just make sure we get a good image of a moving object. I didn't have a way to do that otherwise, so I went ahead and invested in that. I'll try to recoup some of it from Juan Pablo. We'll see how that works later. But if nothing else, he's paying me a decent amount just hourly or weekly anyway to do this project. So I may even eat it and use it for something else. But any other questions or comments?
Nothing else from me.
Okay, we all good. I appreciate you sticking around, Abu. Yeah, these webinars, like I said, I do every 2 weeks. Next one's June 18th. I post them on YouTube when I get done. And so I do have a YouTube channel. Again, that's the only thing I really do on it is stick recordings of this webinar on it every 2 weeks, just not enough time to do much else, which is again why I'd like to have some help with all that. But I really need it to be somebody local. I need somebody that is probably in the Nashville area or close. I had somebody that I thought about that's a young lady that's about to start at Tennessee Tech and, probably needs a part-time job, as many hours as she could do. And if she would just put ads out, every couple of days, for instance, for my books and for the Automation Academy and maybe check email messages and things, that would be a huge step in the right direction. But I'd like to find somebody somewhat technical. So somebody that's going to a technical school and could learn marketing. I think my daughter could help somebody with the marketing aspect, but obviously I've got to pay her. She owns a decent sized branding company that and charges a lot. So I don't want to use her directly for some of that marketing stuff. I'm not even sure she would do it, but anyway, yeah, so that's today's webinar. I'm going to go ahead and sign off here. And it was great talking to you again, Phil, and great seeing you, Abu Liban.
Thanks you, Frank. Thank you.
So do you go by Liban or Abu?
Liban.
Abu Liban. Okay.
Abu's my last name. Liban's my first name.
Oh, Liban's your first name. Liban.
Yes.
Oh, okay.
Yeah.
My wife's from Japan, and they actually go by last name, first name. So she would have been Sakai Mieko,
Oh.
So every language and everything is a little bit different. But where are you from?
I'm in Boston. We are connected on LinkedIn.
Boston. Okay, so you are here in the States. That's cool.
Yeah, we're connected on LinkedIn. I just bought your book, the maintenance troubleshooting. It was really phenomenal. And I came to this webinar by accident this morning, so it was really planned on.
Well, I hope you get something out of the book. It came in really handy for me. Like I said, I used the ampacity tables, the CAD examples quite a bit. And I don't know that I've used a ton else. I already, things like thermocouples, I don't use that often, so I don't use that chart. The ASCII tables I've used before, those are in the back of the book. And then, of course, there's just a lot of little this and that in there. I'm glad you liked it. Yeah.
I work with a lot of IO links from IFM. So I was really surprised to see anybody write about that. And I was really happy about that, actually.
Yeah, Automation NTH uses a ton of IO link, and I would like to use it. I understand it a lot better now after writing that book. They do a lot of pharmaceutical and medical device stuff, and little kind of stuff. And there are some advantages. You get a lot of information from a specific sensor, more than you would.
That's what I've been using too a lot lately. Is I've got some IO sensor applications.
Okay, very cool.
Yeah, I can see a couple of places you can use that in this project. So I can kind of shoot you some ideas offline if you like.
Sure. The problem I would run into with IO Link on this project, this company is notoriously cheap. They are not going to buy anything new that they don't have to, and they're not going to pay for a ton of development time or anything. They'll pay me for my time because I'm the only option they really have. But they're not going to buy a ton of new stuff. These cameras is a good example. Cognex, I'll tell them what they need, and then they'll probably promptly go to the internet and start looking on eBay and Amazon, and
I did have one question about this project. I noticed that they buy a lot of the conveyors from aftermarket.
Yes. Yeah.
And do they get into is it like a food and beverage compliance, like as far as the cleanliness and all that stuff, or?
It doesn't need to be if it's in the post-packaging area. So everything on the right in the tanks, in the filling, in those areas is sanitary. But after it leaves those rooms, it's sealed up, it's in packages. No, it doesn't have to be. They are FDA compliant on everything, but most of the stuff is material handling. It's like palletizers, right? I don't know of a lot of sanitary palletizers. I mean, they probably exist, but for packaging, it's just regular old top tier palletizers, regular old conveyors. They obviously clean things up around there. If they spill juice on the floor, they have to go, hose it down or whatever. But no, it's not. It's like there's two different areas of the plants. The filling areas are, hair nets and sanitizing, and inside of the tanks, obviously lots of CIP and caustic substances for cleaning, but not outside. It's not quite like food processing, or definitely not to the level of medical.
Okay.
Yeah, which is why they're able to buy used equipment, lots of used equipment from Pepsi and Nestle, and they'll buy a whole line, and the line, just one mechanism off that line that they use to repair the Tetra Paks will pay for the entire, all the other stuff that they get with it. So they have a ton of used equipment just in sheds and containers all around the plant. So yeah.
Okay.
Yeah. All right. Well, good talking to you guys. And again, in a couple of weeks, should be 2 weeks-ish. Actually, that's 3 weeks, June 18th. And I think the reason I did that is because Juan Pablo's coming here the week before that. So it's hard to do the webinar while he's here. But I've done something live with him before, so we'll see. But anyway, well, thanks, guys, for showing up. I'm going to go ahead and shut it off here. Hope you enjoy your Memorial Day.